So the last video that we did was MapCrafter on its own, just like a MapCrafter in its own shapefile. This time we're going to do MapCrafter, but we're also going to look at some project results tools. So in this case, I'm going to load our self-help kit, which is basically a finished product, a finished geo package of the whole project. And then now this time what we're going to do is we're going to add MapCrafter to our project folder. Okay, so first I want to collapse all these groups because MapCrafter layers get kind of big. And let's go ahead and let's see, external layers. Oh, I bet you. Why do I have two of those? I'm going to remove that group. Okay. All right, let's see. Okay, that's our elevation data. That's fine. And let's go ahead and start MapCrafter. So now we have MapCrafter. And this time we're going to do two different things. First, we're going to load the culvert lesson, which is the finished lesson. So I'm going to call that one complete. Or let's just say culvert, CULV, complete. And then I want to navigate to that folder. And that's back in lesson 6. We already loaded that in a previous lesson. So what I did is I went ahead and deleted the MapCrafter folder out of here before I try to load this again. So if you need to reload a project, you might want to consider coming into that project and deleting that MapCrafter folder if you want to overwrite the data that's in it, just so that you don't have to worry about whether or not the overwrite's going to fail. Okay, so we'll just select the folder. So it's going to be loading the results from this folder. It's going to use this coordinate system, which it picks up from the project. And it's going to give it a project ID called Culvert Complete. And I'm just going to click Check Available Maps to get everything and click Create Maps. That is going to load all of the maps. And then when I click OK, it's going to close MapCrafter. Now I'm just going to collapse this, and then I want to open it back up a little so you can see that this is flood maps for Culvert Complete. Let's do that one more time, and the next time we're going to do the storm drain complete lesson. Okay, so we rename this to storm drain complete. I'm just going to call it SD complete, and we move this to lesson 3. See, that moves that there. And then it also updated this path where the other MapCrafter folder goes. And again, I'll click Check All Maps and Create Maps. And now we have all of the maps from Storm Drain complete. So if I collapse all again, you can see that I have flood maps from Storm Drain complete and flood maps from Culvert complete. And I also, let's just pull these down here because I want my project to be on top of my flood maps, and pull that down here. Now what you can do is if you expand some of these, you can do difference analysis between the two projects. So for example, you might check the difference in the maximum channel velocities between the two projects. Is that the maximum channel velocity? Okay. Hang on a sec. Alright, something is hiding our data. Oh, I know what it is. It's our elevation. Our elevation is hiding our data. So hang on a second. Let me find our elevation. That one is in here. And we'll turn off our elevation. Okay, and then now we'll go back into MapCrafter and we'll turn off our elevation, and we'll turn off the elevation here, and we'll go into our channel and we'll do our maximum channel velocity, and then we can look at the differences between the maximum channel velocity between a run that has a complete storm drain and the run that has complete culverts. So you can't see this right now because I don't have the culverts loaded in this map, but the culverts are going to bring a lot of water off this street right here down into our channel. So that maximum channel velocity, the channel should have more water in it, so the maximum channel velocity should be a little bit higher. not seeing a huge appreciable change in that value. So they're probably not enough of a change to make it like really discernible. So if that's the case, instead you might want to try a difference analysis between these two rasters. But let's change gears maybe, and let's do the difference analysis. Instead of looking at the difference in the channel raster, let's look at the difference in the maximum depths or final depths. So here's the maximum depth for the culvert, sorry, that's final depth. Here is the maximum depth for the culvert complete, and here is the maximum depth for the storm drain complete. And as I turn this on and off, you can see that there is a change in the depth, but it's not very easy to discern like where the change is on the full raster because everything is kind of the same color. So what you can do instead is you can pull up this tool, Rasterizer, which is another FLO-2D plugin. And if you open Rasterizer, Rasterizer can do two things. It can quick plot rasters from your results, so you don't have to you don't have to use MapCrafter, or it can compare outputs of elevations. So in this case, we're going to do maximum depth SD minus maximum depth culvert. Now there's going to be a lot of rasters, so we'll have to be patient with this. This will be maximum depth SD minus, and then maximum depth culvert. And then it knows that the projection should be 2223. The layer name will be max depth SD minus culvert. And then the output directory just can be one of those MapCrafter folders. It can be whatever one you want. That's where it's going to save this raster that it's about to create. Then when you click Run, it's going to create a difference analysis. Rasterizer is also awesome tool. So we're going to talk about that difference analysis here in a second, but Rasterizer is also an awesome tool for quick mapping a single file at a time. So if you just need to look at something really quick, you can just click MapCrafter, take it to any project that has results, and you can click any of these files and map it. So for example, this is the maximum depth without a channel, and this is the maximum depth combined with the channel. So if I I don't need to right click, I just need to double click on that, and I'm going to call this max depth combined, and output directory will be MapCrafter, and I might also want to call this SD complete. So I'm going to click now, and that's a depth, so I'm going to click Run on that, and you can see that this would be the maximum depth of that storm drain model combined with the channel maximum depth. And then Rasterizer only works on files that have an organization like this. Let me get back to that maximum depth file. So here's the depth.out, and it has this data organization: grid element number, x coordinate, y coordinate, and this is your maximum depth combined. So if you don't have these four columns, you can't use Rasterizer on that raster. You can still use the difference tool on any raster. Okay, don't save that, and let's minimize that. So that's Rasterizer. Let's go ahead and turn this one off, and let's focus on this one. Now this is the storm drain run minus the culvert run. So that means that if the value is positive, the difference is positive, that means that the storm drain had a deeper depth. And if the difference is negative, that means that the sorry, I needed to turn off those other depth maps because they were convoluting the project. And if the value is negative, that means that the culvert model had a deeper depth. And the reason why the storm drain model has a deeper depth in this basin is because we turned a culvert on in the last run, and the culvert has a deeper depth in this basin because more water was able to get into this system and start to drain down out of the system. And some of these other things are like this one has, the storm drain has a deeper depth than this one, because we have turned on a culvert right in here. And actually, I mean, that seems a little counterintuitive to me, but there is a culvert right in here that would be like, should be filling water into this storm drain. So actually, I would assume that the culvert model would be deeper in that one, but it's not. So I'm not sure why that is. Maybe the culvert is, oh, I know why. It's because the culvert is maybe putting water back into the system in this direction. Interesting thing also is that in this one we have higher depths on this side. Oh yeah, that makes sense because that water is getting out of here and kind of running down in this area. So there must be a path to get that water back over here and to let it run downstream. Interesting. This all shouldn't be flooded because this is a huge basin, but it's all cut off and cut in half by the edge of our project. Not important, just interesting. All right, so that's your that's your depth or raster analysis tool, and you have control over these colors just like any other layer. You can control these colors however you want. We've just set it up to try to eliminate everything that's like greater than 0.5 difference or 0.05 difference. I don't exactly know which one it is, but yeah, 0.05 feet difference. Okay. So that's difference analysis. Now I'm going to get rid of these two. I'm just going to remove them. And we're going to go back to, we can turn on our maximum depth. Let's do this. And I want to show you some other reviewing tools. So let's see. Let's take a look at, first we want to look at these reviewing tools, but before we do that, I want to maybe show you how to set this up. So you have to set the FLO-2D settings, you have to set this to one of your output folders. So you can start with lesson 3 and then you can move on to lesson 6. You can review both projects, but you have to change that path. So now that I'm in here, I can turn on the reviewing tool. So you see it's a toggle. You toggle it on or off. And then I can click any of these features and it will plot the results of that feature. So in this case, the results are coming from the swim RPT file. You can do flow, you can do velocity, you can do depth, or you can do percent full. Or now that's conduits, or you can do a node. Let's see if we can plot one of these nodes right here. See if one of these, we don't want to do an I5 because that probably won't have any inflow. So let's do let's do a curbside inlet. Now this would be the curbside inlet. In this case, this curbside inlet is accepting 10 CFS. Now if you grab this or drag this up a little bit and make your plot bigger, this will fit better. Probably don't have any flooding on that because it's at the very end, so not any flooding. That's the depth on that node. This is the head on that node. This is the inflow discharge. This is the discharge reported by FLO-2D, and this is the discharge reported by swim. So if those two don't are two different values, you might have an issue, you might have a problem. But right now they look good. And of course there's no return flow and there's no flooding. So this comes from the RPT and this comes from the swim, the FLO-2D files. And then you can see the table data right here. Now if you do the same thing on you can do it on a floodplain cross sections, which I'm sorry I don't have floodplain cross sections in this model. But you can do it on a floodplain cross section. You can do it on an outfall. Let's grab an outfall. So that would be the discharge at the outfall. And I know it says total inflow, but it's really just total flow. And then that would be discharge to FLO-2D. And some of it is going back at the beginning because we have water getting in the channel sooner than we have water getting in the storm drain system. Okay, now what else do we have here? We have hydraulic structures. You can do a culvert. So here is the flow past that hydraulic structure. And what I have up here is a stepped hydrograph right here. This inlet node is a stepped hydrograph, so that's why this flow looks kind of funny and it's stepped like this. And you can also do it for a channel. So this is the left bank. So you can see that you have the left bank elevation, bed elevation, left bank elevation, right bank elevation, and then if I click on the plot, I can also get, I can click all these and the maximum water elevation. Or I can do, if I uncheck these, I can do the maximum velocity, or the maximum fluid, or the flow area, or the wetted perimeter, hydraulic radius, top width, width to depth ratio. And you see that it's getting bigger at our culverts where the culvert expands. Energy slope, shear stress, and surface area. And the surface area, I don't know why our surface area is going like that in our first bit of our channel, but that's kind of weird, but I don't know. So I'm not worried about it, it's just a little bit weird because our channel, our flow looked good, it wasn't surging or anything. So that's like the linear like properties along the profile of this channel. Or you can grab a cross section and you can get from the cross section data, this is a channel cross section, you can get time, depth, velocity, discharge, flow area, wetted perimeter. And so it starts with discharge. There's your velocity, flow area. And so you can get this values over time instead of over the profile for each individual cross section that the water passes through. And let's see, and then of course the last thing it does is floodplain cross section. So it makes it really handy to review the project data. And I think I'm going to stop the video here because the next video that I want to talk about will be going back to MapCrafter and using MapCrafter to make some mapping templates and to look at the hazard mapping. So MapCrafter, in addition to modeling flood maps, sediment transport flood maps, mud flow flood maps, and two-phase flood maps, it also does hazard maps and FLO-2D layouts. So we're going to look at these two topics in the next video, and then I think we might be looking at like how to manipulate layouts better in, if we get to one more video, we might be looking at how to manipulate some of the settings of the layouts better in a more organized fashion. So I'll cancel this and I'll stop the video and then we'll restart it with the next one with hazard mapping.